Hello there. So we're going to talk about finding the equation of a line given either 2 points or a point and a slope. So here we have a line, right? Just a regular old line. I just drew it. I give it nice numbers. It has a nice y-intercept. The slope is pretty clear. So if you just look at this right now, and we wanted to come up with the standard equation of a line. Standard equation is an equation called slope intercept. And it looks like this: y equals the slope times x plus b. The two things that you really need, you need a slope and you need a y-intercept. Now, in general, if you want to graph a line, you need a slope and you need a point, because like this line over here it has the same slope no matter where I put it, but once I give it one of these points, any one of them, it locks it down into a position and becomes a unique line. So typically the first thing you do is you find the slope. Now here, if we want, we can just find the equation from looking at the graph. I'm going to say y equals the slope. We can come count the slope. This is a descending line if you read it from left to right, so it's going to be a negative slope. It's negative, and then we're going to do rise and run. So it's going to go down 1, negative 1, and then right 3, positive 3. So you'd say it's negative 1/3 times x plus, and then the y-intercept. Well, the y-intercept is pretty clear in this situation. It's just 4. Because 0, 4, that's on the y-axis. You can only have one y-intercept, so it's 4. Bam. So that's the equation of the line. Now, just to prove that any of these points belong to that line, I can plug in any xy value right now, and you can see what happens. So if I plug in, let's say 9, 1, we're going to focus on this point right here. So this is an x value, and this is a y value of a point that's on my line. So if I plug in that x value over here, I'm going to replace that x with the 9 and replace the y with a 1. So I have 1 equals negative 1/3 times 9 plus 4. And I'm just going to see if this is true. I'm not going to move anything around from one side of the equation to the other. I'm just going to see if it's true. So then I have 1 equals negative 1/3 of 9 is just now negative 3, right? Because it's 1/3 times 9 is 3, and then it's negative, plus 4. Then I get 1 equals 1. Okay, that's one way to look at it. Now, the other thing we could do is this. I'm going to erase that. I was just thinking about this as I was composing it. Let's pretend we didn't know the slope. We didn't know we know the slope equals negative 1/3, right? That we figured out. But we need to know what b is. Like, what's b? So one way that teachers teach this is they say, all right, well, if you know the slope and then you have a point that's on your line, well, we have a bunch of points that we can choose from. So just for fun, in this example, we're going to just pick the point 6, 2. So that means now we have an x and a y. So I'm going to say 6, 2 is one of my points, and that's an x and a y. So you can plug in all three of these pieces of information. I could plug this in, and then an x, and then a y into the skeleton for y equals mx plus b, so slope-intercept equation. So we're going to say 2y equals slope, negative 1/3, times 6, that's x, plus b. And then we can solve for b. Now, we know b is going to be 4, but let's just do it anyway. So 1/3 of 6 is 2, but there's a negative in front of that, so that's negative. So let's rewrite the equation before we do any algebra. 2 equals negative 2 plus b. And then we have to add the 2 to both sides. So now we have b equals 4. And then you would take this b and then plug it back into the original. So then we could say y equals our slope, negative 1/3, times x plus 4. And there's your equation. Okay? So this is really the most common way for teachers to teach. I've seen to teach finding the equation of a line. So lastly, we're looking at the graph, right? Let's just pretend now we were just given any two of these points. Let's just take -3, comma 5, and 9, 1. Okay, so we have these two coordinates, 9, 1 and -3, 5. And they say find the equation of a line given those 2 points. So first thing you do is you find the slope. So slope is change in y over change in x. So you just pick a coordinate. This could be P1, this could be P2. When I say P1, that means it's like x1, comma x, or y1, and then P2 would be x2, comma y2. That just implies that there's two coordinates that are, the generic equation. So you have two different coordinates. So you just have to do it in the right order. So if I'm choosing this to be my first coordinate, then I have to be consistent, y2 minus y1 on the top, x2 minus x1 on the bottom. So we're going to say, starting with the y coordinates, sometimes it's nice to highlight them so you just don't accidentally do an x1, 5 minus 1 over -3 minus 9 equals 4 over -12, which equals -1/3. Cool. Now we have a slope, -1/3. Now we need a point. So you could pick either one of these points. I'm going to go with, let's go with -3, just to make it like slightly interesting. -3, comma 5, only because we have a negative x value. Just it's kind of fun to have the double negative. All right, now we have our y equals -1/3 times x plus b. We need a b term, right? Because again, to find the equation, all you need is a slope and a y-intercept, and then you can have your slope-intercept. So let's plug those in. Let's take our x and our y that we know belong to the line. We're going to plug them in. So I'm going to replace this y here with 5. I'm going to replace this x here. Should throw up a parenthesis with -3. Whenever you do a substitution and when there's a coefficient, when you go to replace that, when you go to substitute a value in for the variable, definitely put up a parenthesis. Just that way you don't accidentally forget about the double negative if there is one. You can always remove it later if there's nothing there. If there's no coefficient, then you don't need one. Like with the y on the left here, you see I didn't put a parenthesis there because there's nothing in front of it. Okay, so now we have -1/3 of 3. Well, a third of 3 is 1. And since it's double negative, negative times a negative, then we just make it positive. So it's 1 plus b equals 5. Subtract our 1 from both sides to get b alone. And now we have 4 equals b, also known as b equals 4. It's better to write b equals 4. It just reads better. So that b equals 4, m equals -1/3, and then you can finish y equals -1/3 x plus 4. Okay, so that's using slope intercept to find everything we need. So we just went through a bunch of different ways to find this line. And you notice any of those points that are on that line are going to be sufficient for finding my y-intercept. And also any 2 points that are on the line are sufficient for finding the slope. Okay, so we can always arrive at the same conclusion. The last thing I want to go over with you is another equation. Now you could stop the video here and just call it good if you want. The other equation I wanted to talk about is something called point slope. It's just worth knowing. So point slope, this is my favorite, looks like this. It goes y minus y1. That means I'm only plugging in one y value. I can leave the other y alone. When you see a subscript on an x or a y, that means that you're substituting in an actual coordinate. The slope times then equals the slope times x minus x1. Okay, so that means you need a point and a slope. So we know the slope, we found it already, equals -1/3. We have a point, we have a bunch of points. Okay, we can take any one of those points that are on that line. Let's do let's use 3, 3. We haven't used 3, 3 yet. 3, 3. So we're going to plug, in this case, this is x1, and then this is y1. So you substitute in, this guy goes here, and this one goes here. Just remember, the only thing that's trippy is that you have the negative in front of it. It's minus y1. So you're going to have to reverse the sign. It says opposite of whatever that coordinate is, right? So here we go. We have y minus 3 equals slope, negative 1/3, times the quantity, x minus 3. Now, if you're in a calculus class, you can leave it like this because you could actually graph the line right from here. You could look and say, oh, my point is 3, 3, my slope is negative 1/3, and then you would plot the 3, 3, and then count, rise and run, and you'd be able to graph. It doesn't matter if you know the y-intercept or not because this is just an alternative form. The reason this is undesirable is because this is not in y equals form. So y doesn't really act as an independent variable. So usually what people like to do is distribute this, and then you get y minus 3 equals negative 1/3 x, and then negative 1/3 of negative 3 is just positive 1. And then we're going to add this 4 to both sides. Sorry, I don't know why I did 4. I know why I did 4 because I knew it was going to happen. I'm going to add this 3 to both sides. So I can isolate my y, and then you get y equals negative 1/3 x plus 4, which is our equation. Now the reason this is my favorite is because you don't have to go and find b and plug it back into something. This is a one-stop shop sort of deal. You know your slope, you know your point, you plug them in, and then you solve for y. You isolate y. You move everything to the right side and leave y on the left. So that's how you use point slope. That's how I learned when I was in algebra. I'm pretty confident that that's what I did. And now I had students teach me this way, the using slope intercept and plugging the m and then the point in there to solve for b, and then going to back substitute the b and the slope into an equation. But you know, you do what you got to do. So I would definitely try this on all of your examples. I'd clear with the teachers you're working with which one they prefer. Most likely, I really genuinely believe it's going to be this one. It's possible that they might not even be super familiar with point slope. So it's not really taught a lot anymore. Anyway, hope that was helpful.